All right, I think we'll get started. We're going to talk about HTTP 2, what you need to know. My name's Robert Boedigheimer. That's my Twitter information. I'm a full-time web developer for an e-commerce site in the US. I'm a Pluralsight author as well. I've got my email, Twitter, and blog information. I'll show that again at the end. I also have the slides, and I don't have a lot of code for this one, but the slides and the code are online, so you can get a link at the very end. Okay? And if you have questions, feel free to ask as we go. We're going to start with HTTP, what they've now dubbed 0.9. So this is from 1991. I gave you a link to where you can read about what was there. It was created by Sir Tim Berners-Lee, who calls himself just a web developer, if you were at the keynote this morning. It was a text-based request and response protocol. And you could do gets, and you could get back HTML. That's all that the 0.9 was available to do. And it would close the connection after every response. So his original intent was really for sharing physics documents between people at CERN. Later, people started extending it and adding different things. So they created this RFC. It's actually an informational RFC. It wasn't a standard, but people were implementing stuff all over, and it was kind of busy. So they wanted to get something documented so people had, if you wanted to implement it, they had something to go look at as a compilation of best practices. They added the ability to do request and response headers, so we're going to see that. And you could get any type of response back. So you could start getting images, text files, CSS, whatever else you needed to serve. That was added in 1.0. And then finally, in 1999, they came out with HTTP 1.1. Some of the big things they added were persistent connections, so to keep alive for your underlying connection. Host headers, so we have a lot of subsidiary companies, and that was a nice one for us because we used to host 30 internet websites, and we burned an IP address for every single site. So being able to do host headers just allows you to share a single IP address, and the host header gets sent up from the client and says, I want that website, and that's how it knows which IIS site I needed to run. Huge success, right? I mean, I don't know anybody, if you have any of your software that's been running, 17 years now. So there's things that we don't like about it, but it's been a huge success. I mean, all the things you're doing on the web, it's been a very successful protocol. I'm going to talk briefly about Fiddler. I'm going to show it a couple times, but it's a tracing tool built specifically for HTTP. Shows the complete request and the response, which is why I like it. If you've used like Netmon or Wireshark, you kind of have to reassemble the packets to figure out what got sent and what came back. So that's why I've been using Fiddler for a long time. It's a proxy. It's free. Eric Lawrence was the original author of it, and then it was acquired by Telerik in 2012. He went to work for them full time, and he has now decided to move on to, I think he went to Google like a year ago or so. So it's now a Telerik product. They've promised they'll keep it free, so hopefully that'll stay that way. One note on it, the reason I put it on here is it's built using .NET, and so it's dependent on the .NET framework for its functionality. One of the things, we won't get real in-depth with this, but part of the handshake for HTTP 2 over an HTTPS connection uses ALPN, which is just a shortcut negotiation. It's not supported by the .NET framework. So right now, today, Fiddler does not support HTTP 2. So if you're going to use it to actually watch traffic, because it's a proxy, it'll actually downgrade you to 1.1. So just be aware of that. I sent to Eric, I think a week ago, to see if he's heard anything. He said Microsoft has not put it into the framework yet. So I don't know why. And that affects all of our uses of HTTP classes don't support HTTP 2 yet, which is disturbing. But so you're aware. A couple of the problems with HTTP 1.1, it really wasn't designed for today's web pages. So if we go out to if you've been out to HTTP Archive, they check a lot of the top sites and just keep statistics about how the web is changing. And the one I find interesting, since I said I've been doing web development forever, so it just freaks me out. The average web page is about 2.5 meg now. And so they said, I don't know how many weeks ago, that that's as big as Doom was, if you ever used to play Doom. So that's kind of shocking to me. 102 requests. So just to see one page, you're making an average 102 requests, getting back about 2.5 meg. Okay? So that's part of the problem for the protocols. It just wasn't set up to be an application platform like how we're using it today, right? It was designed to serve documents originally, and that was pretty much it. So the 4 main issues with it: it requires multiple connections. It has what's called head-of-line blocking, which I'll show you. It has a lack of prioritization. So out of all those requests I have to make, I have no way from a browser perspective or as a developer to specify, I want this to be more important than something else. And lastly, it's got very verbose headers. So we'll look at all of these. So the first one, it requires multiple connections. And so you make a single active request and response on one connection. So the original spec said you can open 2 connections to each host. Okay? So if you come to my website, you're coming back to the same host, you can open up a second connection. So you can basically get 2 responses at once, right? Didn't take browser developers too long to figure out, we'll cheat, we'll be faster by adding a few more, right? So most of them today do about 6 connections a host. And I'll show you that when we talk about head-of-line blocking. Problem with that is they use resources for each connection. And if you know how TCP works, TCP has a 3-way handshake every time it needs to establish a connection. And it also has what's called TCP slow start, which just means it starts not allowing you to send a lot. And then if it's got a good line, it'll slowly ramp up. So the bad news is you're not taking full advantage of these connections, and you have to go through that hassle on 6 different connections to that host. Okay? So that's one of the main problems. Second problem is called head-of-line blocking. And all this means is once I have a single connection and I issue a request on it, I can't do anything else with that connection until that response comes back. So effectively, if I needed to get 50 different files from my one host, I can go in blocks of 6 because I send out a request, and if that request happens to be responding really slowly, everybody else stacks up behind that one. And that's what's called head-of-line blocking. So I've got a demo of how that would work. So I've got a page, just HTML, if I can get it open here. I've got a bunch of different image requests. I added this in here for a freebie for you. I'm using IIS. I wrote a delay module, which just does a sleep on each request. And it's helpful because you can actually target when you're developing and say, if this request were slow by 10 seconds or 15 seconds, what happens to my page, right? So you can also use it, put it all in on like Thursday, and your site will be really slow. And then you can tell your boss you worked all weekend and you fixed it. You can just take that module. I'm using it here because I want to show, because I know there's 6 connections, I want to show that as I make all of these requests, ideally the browser could just issue all of the image requests and get them all back. You'll see the first ones are actually delayed by 10 seconds. So we'll see what that does. I'm going to open up Fiddler here because I just want to show you what the head-of-line blocking looks like. Of course, I already ran it, so let me run it again. So you can see here in Fiddler that these 6 requests are pending. You can see the -1 and there's no status yet. And you'll notice, besides all the other garbage that Chrome is doing for me here, the other images, you finally get the other 3 images get requested right here. That's because, again, you have 6 connections, and if those are not responding, you're stuck and you can't issue any more requests. So that's what's called head-of-line blocking. They tried to work around that. If you're familiar with, they tried HTTP pipelining, which was a way that you could send out multiple requests on a single connection, and it turned out to be extremely buggy, and nobody actually has it implemented right now. The modern browsers all disable that. So the pipelining turned out not to be a good answer. So we'll talk about how that gets solved. There's a lack of prioritization, so there's no direct way for me to specify the desired order of responses. So browsers need to basically decide. It's a guessing game, and they say they keep changing what they want to do because it's a game of how they're going to win. They know they have 6 connections, so they look and they're parsing your HTML, and they see a new resource they want to get, and they try to decide, oh, this is an image. I'd really rather get CSS first. Maybe a style sheet will be coming up next, so maybe I should just hold that connection and not issue it yet, hoping I can use it for CSS. So they play all these games just because there's no prioritization built into 1.1. Talk about verbose headers. There's no header compression. So even though you turn on compression, which I recommend you do for your websites, we cut our bandwidth in half just by turning on HTTP compression, so do that. However, the header portion of the requests in HTTP 1.1 are not actually compressed. So you end up seeing, especially I highlighted the cookie here, the user agent, you send 50 requests back to the same host, that stuff gets repeated with every single request because HTTP is stateless by default, so it has to reissue all those things over and over. So that's the two problems really is you keep sending it with every request and you don't compress it. So those are kind of the problems. We'll talk about this a little bit. Bandwidth. I went to the hardware store to make this beautiful picture for you. They were wondering why I was laying pipes on the floor, but it's relatively easy to add more bandwidth, right? Get a bigger pipe, spend a little bit more money. That's something that's reasonable to do. Latency, however, is actually based on distance and speed of light and everything else. There's not a lot that we can do generally to fix latency problems, okay? So as we talk about it, since it's hard to remove, the focus is going to be to try to avoid latency, especially when you get into mobile and you're using mobile devices. The latency is a lot higher typically, so you want to be able to deal with that in a better way. So I love how things change on the internet. Supposedly, the lore is, two people at Google were debating this. Which one's more important, latency or bandwidth? So they must have had a bar bet or something, and they went out and said, we're going to do a controlled test of changing the bandwidth but leaving the latency the same, and then leaving the bandwidth the same and changing the latency. And let's see which one of these has more impact on the average website. Okay? So the average website's the important part of this. So they ran it against a lot of the top websites, and this is what they came up with for their graph. So if you notice, as I add bandwidth, it helps for a while, and then once I get to about 5 megabits per second, it really plateaus. You're really not getting much more improvement on the average web page by adding more bandwidth. Obviously, if I'm talking Netflix or streaming video or something, more bandwidth will help. But the 100 requests kind of scenario that's normal for most web pages, they don't benefit a lot from bandwidth. Latency, however, if you notice, as they reduce the latency, they pretty much got a linear improvement by fixing the latency problem. So that's why and I've got a link down here where you can go read about that study and how it worked. But the important thing was that really changed their mind when they were about to start talking about how do we do the HTTP protocol differently. They wanted to really focus on how do we eliminate or cut out latency. We can't fix it, but we can try to avoid it. Does that make sense? So Google started SPDY back in about 2009. It was meant to be experimental. It was not something that they wanted to become kind of a de facto standard. They said, we think there's some things we could tweak, so we want to do SPDY. We're going to let people use it, so other people outside of Google started to use it with server implementations and clients. But it modifies how the requests and responses were sent over the wire. They didn't want to change the semantics of HTTP. They said if we change the rules of HTTP, like the GET, the POST, the status codes, it's going to take forever to roll out something new. So we're going to focus on just the plumbing of how do we send the stuff over the network without altering the other stuff. They happen to require HTTPS, and so there's a big movement for HTTPS everywhere. Part of that was their philosophy, but the thing they really noticed when they turned SPDY on, they would, I think it's 20 or 30% of their traffic would get screwed up by what they called middle boxes, proxy servers and other devices in the chain that looked at SPDY and said, that kind of looks like HTTP, so I'm going to tweak this or I'm going to change. And so literally 20 or 30% of the people that tried to connect to a SPDY server ended up failing. So they basically said, we need to tunnel it through HTTPS just so these middle boxes don't play with it. So they just made that a rule that we're going to require that because otherwise you fail. Their features were they wanted a single connection. So rather than having multiple connections per host, they wanted a single connection. They wanted to get header compression. They wanted to add request prioritization. And then lastly, they wanted to add the ability to do server push, which we'll talk about. So as I said, they did that experimentally. On the side then, the IETF said we want to start up HTTP 2 and improve the protocol. So they started their own working group in 2012. It ended up, they did an RFP. They got different recommendations in. SPDY came in as what they wanted to base HTTP2 on. So you'll see HTTP2 basically took where SPDY was and then made slight modifications to it to become HTTP2. So that's kind of the history. Now that HTTP2 was standardized May of 2015, I gave you the 2 links. I actually printed out. I've read them before, but I had a 15-hour flight to get here, so I thought I would. I didn't actually read it, but if you want to see the details, it really is not that big. I mean, you've got both of the specs here. The bottom one is the header compression. The other one is HTTP2. They're really not that long. As a web developer, reading that and understanding, I've gotten a lot of answers by looking at the RFCs before that I just wouldn't have been familiar with otherwise. Now that HTTP2 is standardized, Google has actually, they're deprecating SPDY. So I think they just shut it off like May 26th for Chrome, where it's no longer like the client for Chrome won't support SPDY anymore. They want people to move away. Their intention was not to be a standard. They want people to adopt HTTP2 now. So let's go to HTTP2 goals. You'll see they're very similar to what we saw for SPDY. They really want to minimize the impact of latency, avoid head-of-line blocking, use a single connection. I put per host, because it's not meaning that you'll have one connection to all the places you go. It's just one per host. And again, they said, we're going to keep the HTTP 1.1 semantics the same. And that's an important choice. And people have come back and said, well, why didn't you fix this? And why didn't you fix that? We're doing this first. It's difficult to change core things that are built into all the servers and the clients that we run. And so they said, we won't be effective if we do that. So they chose to leave all that stuff alone. The good news of that is you don't need to change your application code to run effectively switching from 1.1 to 2. You can pick up your whole site, drop it over there, it's going to run. It's going to run pretty decent. With the caveat that we've done some tweaks, best practices, hacks, whatever you want to call them, to deal with HTTP 1.1 that you probably want to dial some of those back. And I'm going to go into detail on those towards the end of the talk. Okay? So we'll talk about the major features of HTTP2. First of all, it's now binary. It's not a text-based protocol anymore. Okay? Bothers some people where they're like, oh, I used to be able to use telnet, and I could telnet to a server and I could read it. Did any of you ever do that? I didn't do that. But, the way it is now with HTTPS and compression and everything else, I need a tool to effectively read the traffic anyways. I mean, I've been using Fiddler for years, or Wireshark, whatever is your favorite. I need a tool anyways. It's not a big deal. It's a lot easier for people to implement the protocol using binary than it was text-based. There are just so many edge cases with the text-based. They said, we're just switching to binary. We'll talk about streams and how you do prioritization and dependencies. We'll talk about a fully multiplexed single TCP connection. We'll talk about header compression. And then lastly, I put server push in italics because it's the one that kind of freaks me out the most. I'm not quite there yet. It sounds great, but I haven't seen how I'm going to use it exactly. So I just wanted, that's the more experimental wing, we'll call it, of HTTP2 at the moment. Okay. So the first one, again, it was previously text-based. Now it's binary. There's like 9 different frame types. They're all in the spec. If you want to get to that level and look at all the different frames and how they work and stuff, go ahead and read it in there. The 2 that you'll see the most are the header and the data, which is just the request or response header and the actual data payload. Those are the 2 frames you'll see the most. We'll mention a few other later. Talk about streams. So this is how they are dealing with priorities. So a stream in the term of HTTP2 is a single request and response. Okay? You're going to have a bidirectional series of frames for your stream, and the order of the frames is significant. Each stream is given an integer identifier. You can use what's now called client priority hints. And so what I've got kind of a tree here. I can say, here's my root request. Let's say I want to make sure I have a certain file first. Let's say I want my CSS file first. The browser can say that's the highest priority. Until that's actually downloaded, use all the resources you can to get that first. Then, after that's done, I want you to get these other 2 resources. not only can they make them dependent on their parent, but they can also do weighting. So you can see that out of these two, B is twice as important as E. And then after B is done, you've got same thing, D and A. So the browsers have started implementing, and they've been changing a lot. I mean, they're learning as they're doing this where things are slow, so they come and tweak with. This is pretty much a browser developer thing, right? They're deciding for us what is most important here, and how can I specify these in a way that hopefully will maximize our connection and get the page to render in the fastest way, okay? So again, this is part of the prioritization we didn't have before. What's cool about it is it can be updated at any point, okay? So a couple notes and some cool things. They're not doing all of these yet, but how many people have heard progressive JPEGs before? A few? Yeah, like I said, it was cool in the modem years, you know, when I had black hair still, it was a kind of a hot thing. But with a progressive JPEG, instead of drawing like if you've ever seen on a slow connection how you get one line at a time for a JPEG, a progressive will bring it in the whole image fuzzy and then improve the quality. So what they're toying with is if we switch to progressive JPEGs, which I want to do on our site, once I can get that work allocated, I want to switch over to all progressive. It'd be nice, browsers have been talking about, why don't we do the first request, get the fuzzy part of all of the images, then deprioritize that stream to let the other stuff come in first, and then we'll slowly ask for the rest of each image that's about, you know, in the fold, so to speak, and then we'll ask for the rest. They could be that complicated if they want to be, if you use progressive JPEGs. The other thing they could be is you could be midway downloading a page and you suddenly hit a different tab on your browser. It could deprioritize all the requests that you had on the one tab and up the one on the other tab. So I mean, these are all things they're learning, and they're playing with their algorithms and stuff, but this is stuff you just couldn't do before, okay? I think by far the biggest change is this. Having a single TCP connection solves a lot of problems. So like I said, in the past, you'd have just 6 connections, you'd have head-of-line blocking, you'd have to choose which one of these do I want to put out now. Now what happens instead is I have a single connection, so I can issue a whole bunch of requests to the server, and I'm just showing you that it just interleaves those streams on that single connection. So you can't have head-of-line blocking anymore, because let's say the data for 7's taking forever. You don't care because it slips in your data for stream 3. It's just able to multiplex. It's supposed to do it obviously based on the priorities, right? And when we talked about priorities, if it turns out the server's supposed to get a certain resource, like C, but C's just not happening for some reason on the server does not have to do what you're telling it. It's a hint. If C's getting delayed too long, maybe it'll start working on E and B. So it'll start interleaving those streams on that single connection, okay? So all the advantages of this, a lot less resources. The 3-way handshake and all the stuff you have to do to create a connection isn't there 6 times, it's there once. It's going to be more efficient more quickly. You're going to get through that TCP slow start. And again, to me, the biggest important thing is the head-of-line blocking is just totally gone. So whatever is available and what the browser asks to be prioritized will start getting multiplexed on that single connection. Okay, so to me, that's the biggest change that they've made. We'll talk about header compression. They originally started with doing compression using gzip like they did for everything else. And they ended up having some, I think it was called crime. There were a couple different compression-related security flaws. With using that particular compression algorithm, they actually had issues where they could find stuff out about the rest of your connection. So they had to back up and say, we can't use that. We're going to create a whole new header scheme for compression from scratch, and that's what HPAC is, okay? And that's this other RFC. So the two things they're trying to solve, why do we keep sending the same data for every single request to the same host? Let's add a little bit of state into this connection so we don't have to transmit the user agent 50 times, right? The user agent's not changing between the other 49 requests. And then the other part was they wanted to do compression. So I showed you part of the table. They have a static table where they say, instead of saying get, let's say to. Instead of saying index HTML. So they basically went out and scoured the web and said, what are the most common methods used, statuses, files? Let's make those be just a single number index into a static table, so you don't have to send long stuff anymore. And then they also have the idea of a dynamic table. They know there's headers that aren't going to hit this particular table, so they want to be able to go and add your own dynamic stuff. So I'll show you what it would look like. So here's what you'd send today, right? I'm doing a get, I'm doing HTTP, I want the home page, here's my user agent, I want to do compression. Down here, I happen to implement my own custom headers, right? I can do that in HTTP 1.1. I'm just sending something from the client. What this gets converted into for HPAC, get is just 2, HTTP is 6, asking for the home page is 4. User agent is 58, but this value we know is going to change, right? The user agent, the actual value is going to be a lot different for all the different user agents that we have. So they just compress that. You like my compressed version? Isn't that cool? Anyways, if I want gzip, I say 16, and then you keep going through this list. So the idea is I'm sending a lot less. Now on my next request over that same connection, I'm not going to resend things that didn't change. Okay, so like the user agent is the same. I'm not even going to bother to send either one of those two. It's going to use what it had from my stateful connection before. If I need to override that for some reason, it'll go and take the new value and send that to the server. Does that make sense? So again, I think I have. And they do have some limits on the dynamic size. So they've thought through people attacking it and trying to overwhelm your server by sending it a bunch of headers and stuff. There's only a certain amount. But again, out in the RFC, they have the full definition for what is the static table. I think it goes up to 61 of the different common known values that most people are going to send. And then they talk about the dynamic table and how they do their compression and everything else. So again, just the big advantage of not having to send that stuff over and over. Talk about server push. So the idea with server push is if you request my home page, I'm going to give you the HTML. As soon as you get it and you parse it, you're going to turn around and ask me for the CSS file, the JavaScript file, all that stuff, right? The idea with server push is if I had a smarter server, I could know what you need next, and I could start sending it with the first response down your connection. Okay? So again, you come to my home page. I always have site.css or whatever. And there's different ways the server figures it out, which is kind of the mystery part to me and the part that's a little experimental today yet. Some servers I've seen actually watch the refer, and they keep track of every time somebody asks for this HTML page, they keep asking for the CSS and JavaScript. Some servers do that automatically. Others, I don't think I have the thing in here. I've got in the actual code, ASP.NET 4.6 has what's called a push promise. So as a developer, I can actually influence which resources do I want to try to push to a client. Okay? So like I said, the idea with it is because the HTML request came up, rather than have a whole new round trip, this is part of that latency avoidance, right? Rather than wait for it to get down to you and parse it, and for you to come back and ask for the CSS, I'm just going to start to push it to you. Once you start pushing it, so it's same origin restrictions, I can only push stuff that's from the same host. They call it better inlining. So if you've been watching a lot of web performance lately, some people are saying you should embed the top part of your CSS file into your HTML, right? Or you should take images and make them into data URIs and shove them into your HTML, if you're familiar with that, doing inlining. The problem with that is when you inline that stuff, it's not cacheable, right? It's mixed with your HTML. It's not shareable because now I'm putting it into every one of these files. So they really call server push a better way to do inlining. Okay? I'm going to push you some stuff, but rather than shove it into the HTML, I'm going to push it down the pipe. If you don't want it, you can reject it. So you can send, as soon as you start seeing it, you can send a reset stream. I already have that cached in my browser. I don't need that. So that's where I get kind of iffy on it, right? The game. I do a lot of browser caching and stuff. I use expirations, versioning, all that kind of stuff. I'm not sure how much I want my server trying to figure out and pushing stuff if I already know I'm keeping it in your browser cache. I'm actually wasting bandwidth if the server starts pushing it. So this is the area that still people are trying to figure stuff out. You know, how are we going to use this? How would I influence it? Like I said, I can actually, and I think I have the code in here. If I still, I do not, but it's push promise, and it's part of the, I wanted to see if I had it on my notes, I don't. It's built into ASP.NET 4.6. So if I do want to take advantage of it, literally as a developer in ASP.NET, I can say, I do want to push this to you, and I'm controlling that rather than letting servers do that for me. Okay? Like I said, this is the experimental part I'm a little iffy on. But there's a big fight about whether they should require HTTPS or not. And so within the actual standards group, they went back and forth and they didn't get anywhere, so they finally said, we are not going to require it as part of the spec. So that in the RFC, it does not say you have to use HTTPS. It does say if you're going to use HTTPS, you need to use at least TLS 1.2. And they have a blacklist right in the RFC of these are ciphers you can't use with HTTP 2, weak ciphers that they don't want in play anymore. So that's kind of how they dealt with it. Have you ever done standards within your own company? Like where should the braces go? I've been in those. That's not fun. I can't imagine being in like a worldwide standard over this. I can see where they get to the point where they said, we're not going to require it. We're done arguing about it. Let's move on. However, the browser vendors said, we are. So Chrome, all of them, all the major browser vendors at this point have come out and said, we won't implement HTTP 2 over non-HTTPS. So even though the spec talks about how you can upgrade and do it, they're basically saying, I don't care. So effectively for me, as we run an e-commerce site with all sorts of browsers, I'm going to have to convert to HTTPS. I'll talk about some of my strategy at the end. I won't have a choice because the browser vendors are making that choice for me. If I want to use HTTP 2, clients aren't going to work unless they have HTTPS. And again, there's two reasons. They avoid problems with middle boxes and proxies that they learn from using SPDY, and also just to elevate general security on the web. Talk about browser support. So if you've been out to Can I Use before, everybody familiar with this? Not too many. I went to Can I Sue once. You can. You might not win, but you can definitely sue in the US. So I can come out here, and what they do is they track how well implemented the CSS3 and HTML5 features are. So I can come out here and type, in this case, HTTP2, oops. And it's going to show me current statistics on how well it's implemented across all the different browsers. So it's really got pretty good support already from major browsers. Talk about some implementation things. So there's actually a link. If you go to that link, you can see a list of all the products you probably use, and they're the ones that currently support HTTP 2. So you can go out there and say, like we use F5 load balancing, for instance. I can see that their product now supports HTTP 2. There's also, for me, IIS 10. So I'm an ASP.NET developer. IIS 10 now supports HTTP 2. So I'm running Windows 10 on my own machine here. I can use HTTP 2. If I want to do it on a server, that's going to be Windows Server 2016. I don't know about your ops groups, but I won't see that for years. So indicators. So you can actually go get for both Chrome and Firefox. If you're interested, you can get some extensions you can install, which tell you what server support is. So if I go out to, for instance, let's do Facebook. So I didn't mention it. Major websites have been running SPDY for a really long time. So one of the advantages of HTTP 2 is as it's come out as a protocol, it really has been really well supported and tested before it even came out, because a lot of the core stuff was done in SPDY. So what these indicators do, if you go look at right here, I can hover and it'll tell me Facebook has already converted to HTTP 2. So I can go out and look at some others. I think WordPress switched over not long ago. So since Chrome supports it, it's going to show me that. So if you want to go see what a particular server is running, that's a quick way to see, what version are they running, and are they doing that, or are they still doing SPDY? So talking about some expectations for HTTP2, isn't the magic web performance pixie dust, right? You can't just drop it in and expect to decrease by 50%. This is Mark Nottingham, who was the head of the HTTP working group. He basically said, you're not just going to switch to 2 and instantly be 50% faster, just so your expectations are set. It should help the most when you're in high latency networks with lots of requests to the same hosts, right? If you think about, here's the advantages of the protocol. We're avoiding latency. And if you make a lot of requests to the same host, you now don't have headline blocking issues. Everything's multiplexed on a single connection. That's the sweet spot where if your site runs in those sorts of environments, you're more likely to get better performance. Potshot, from what some people have said, about 5 to 15% performance improvement. I've actually seen some major implementations have been putting out lately about how they've been doing, and some have actually been getting worse, right? So the things I claim and tell you here, always take with a grain of salt. The recommendations are the standard. You should go that direction, but don't do it without testing, because there were some sites that had tons of images on them, really large images, and they switched over to HTTP2 and it actually got slower for them. So they had to back that out, and they have a whole article about why is that, and they did a lot of research to figure out which piece of it was causing the problem. But it's just important when you're going to switch to test your stuff, right? See if it's getting better or not. So now let's talk about all the performance techniques that I've been preaching for years that you don't want to do anymore, probably, okay? So the first one is we bundle JavaScript and CSS files. We did that a couple years ago. So we minify and we bundle them all. So all of my JavaScript files get bundled into a single minified JavaScript file. I put a version number on it, and I tell it to keep it in your browser for a year. That way you come to my site once, first page, you get everything you need for JavaScript. You never have to ask for JavaScript again, and I compress it, okay? So that's good. I'll give you one little warning on CSS files. We bundle all of ours, worked great. About a month later, we added a whole new piece to our site, and it worked everywhere but IE. So we're like, why doesn't this work in IE? Turns out IE only lets you have, I think it's 4,096 unique selectors per CSS file. Yay! And I just crossed that. So thank you very much. So be aware of that. If you do have a lot of CSS, so we actually have 2 separate CSS files. Now that we've done our redesign, we went to SAS and cut down our CSS a lot, so we don't have that issue. But when you're about to bundle, be aware of that. So like I said, it cut 50% of our homepage performance. It was 50% faster just by doing that. It took a couple hours. So it was a great idea in 1.1. We'll talk about now. The penalty for having multiple requests is not as high as it used to be, because you don't have that waiting for a TCP connection, headline blocking. Having a single multiplex connection really reduces the impact on you of making multiple requests, because there's bad things about bundling, right? I bundled all my stuff together. Somebody says, well, I got this one problem in this function in JavaScript. We got to change it. Great. Now I change it. You have to download a whole new bundle just because I made that one change. I can't individually cache things like I would really like to. That's really an artifact of something we're working around that 1.1 didn't do very well. Okay? I've seen some people in recent implementations saying, don't go all the way over to the other end and do 200 or 500 separate JavaScript files. I mean, don't do one, don't do 500 separate. Figure out for yourself that good sweet spot for how many you should minimize and combine. But it's not an obvious choice anymore like it used to be, because you don't have that impact anymore. For the same reason, don't do CSS Sprites. If you've seen Sprites before, you take all your small images, bundle them into one image, and you index in using CSS. So we did that on our homepage. We cut like half the images we had. They were in a Sprite. It's a single request. Great. Again, there's not a request penalty, so the pain of doing them, they're not super hard, but they're also not intuitive and things that you just want to do for the fun of it, right? I don't want to bundle and do sprites if I don't need to. So that's something you want to look at avoiding. Domain sharding is another one. So today, you knew you had 6 connections per host. So if I had cdn.com, let's say that's my domain name, I would create cdn1.com, cdn2.com. Now I've got 18 connections. Wow, great, right? So I'll just keep making. There's trade-offs because every name I make, you have to do DNS resolution. And so they kind of did research and said the sweet spot for most people is 2 or 3 different domain names. Seems to work pretty well. I actually tested it for us, for our site. It would have been about 25% faster. But it's pretty entertaining getting web developers to do what you want them to do, right, from a standard standpoint. And once you do domain sharding, let's say I took logo.gif and stuck it on cdn.com, and another developer on a different page used cdn2.com. Everything I did about caching, keeping it in your browser, domain just went out the door because it's sitting in the browser cache, and he's making you go get it again because he used a different name. So I just decided, we never did it because of that hassle. But again, now that I have a single multiplex connection, I'm not going to benefit as much by splitting across. I'll probably be worse off doing domain sharding because I don't get a lot of advantages, and yet I'm paying for the DNS lookup now 2, 3, 4, 5 times. So they recommend not doing that. Lastly is inlining, so doing data URIs, putting your CSS and JavaScript directly into your HTML to save that extra request not being made today. Once server push is proved out to be a great idea, I'll consider, I don't do inlining anyways, but if I did, I'm going to wait to see that server push works out like I'm hoping it will, that it's useful, before I tell people to stop doing this. So at least test that if you want to do it on your web server and see if that works for you or not. But that's another thing you could avoid when you have HTTP 2. Things you should continue doing that you should have always done for web performance. There's really 3 golden rules, right? Make fewer HTTP requests. I put that in italics because now that's not as big of a penalty. But I leave it on there because don't make requests you don't need, right? I mean, we get to put a lot of third-party tags in our web pages and stuff. I'd really like less of those. I don't want requests I don't need to make. Send as little as possible. So use compression, minify. Sending less down any pipe, it's going to be faster. So keep doing that. Send it as infrequently as possible. If you can use the browser cache, there's nothing faster than the browser cache the user already has your stuff in, right? It doesn't use any of their data plan. It doesn't use any of my server bandwidth. It puts no load on my server. Use that and take advantage of that. So I listed the 4 things you should still do. Still minify. You're probably not going to bundle, but you should minify. Absolutely turn on compression. I mean, I think IIS has had it standard for static files for the last, 3 or 4 versions. We turn it on for dynamic too. So every one of our ASP.NET pages, we do the compression and send it to the client. It's worth it because some of our pages turn out to be kind of big. Some people say, well, that has a CPU impact. They've done some measurements, 2 to 5%. If you're within 2 to 5% of having a problem with CPU on your web server, right, you got other problems. So I recommend just turning that on. Doing expirations is just setting and saying this folder, I'm going to control that if you ask. So for instance, we do this for our bundled files today. We say it's good for a year because I have a version number on it. So it'll actually put it in your browser cache and say, don't even come and ask me for the next year. If the HTML still references that same file with the same version, use it from the browser cache. And if it's not there, it'll come and get it. People freak out a little with expirations and say, well, what's going to happen if the file changes, right? We're a food site, right? I've had a picture of unbreaded chicken breast fillets for 5 years, and marketing says, we need a new picture. Sales are going to go like... Somebody gets the old chicken picture for 29 more days, I really don't care, right? So take advantage of it. If you're forced to do it, just change the file name. So if it used to be logo.gif, name it logo1.gif. Now nobody will have that in their browser cache, and you get the best of both worlds. So as long as you have control of the name, that's why you see a lot of the files have version names built in now to get around that kind of stuff. But you should do that. Lastly, having a CDN, Content Delivery Network. We did this a long time ago because we were limited on bandwidth into our data center. So we actually offloaded all of our images. So now all of our static files get served from a CDN. So a CDN is just, they have servers spread all over the US and all over the world that are closer to my customers than my data center is. So you get the ASP.NET HTML from me, but I'm referencing all the rest of the files from the CDN. So it calculates the closest CDN server to where you are. If I'm lucky, somebody's already been to our site, all that stuff is sitting there. Otherwise, it comes back to our server once, keeps it. Now, everybody else who comes to my site will take advantage of the CDN. So it saved us a lot of bandwidth, and it's like, it was 25% faster for us. And these days, they're dirt cheap because they're all competing with each other to get your business. It's easy to just RFP and get your costs down every couple of years. So those are still worth doing. So some strategy from my perspective of what I can do in the short term anyways. I'm going to continue to use a CDN because I want to avoid latency. A lot of major CDN vendors have now implemented HTTP2. So you can go out to that list I gave you and see if your CDN you're looking at supports it or not. All my static resources sit on a CDN. They're minified. Today they're bundled. We use HTTPS with our CDN. They're capable of doing that. They'll host your certificates and serve images and stuff on secure pages. That works just fine. So for me, my strategy, the best case for me, if I looked across who uses our site, and I haven't done this yet, but based on other people, I would say probably 60 to 75% of my users probably support HTTP2. So I can make a choice right now today and just say, I'm going to stop bundling. I'm going to stop doing some of the stuff I'm doing to make the HTTP2 better by 5%, while potentially hurting my HTTP1 people by 50%, right? So that's not a choice I'm going to make. What you can do, and I gave you just an example, is I made a request to my web server. The web server served HTTP 1.1 because I was doing it on port 80. I wasn't doing SSL. I could just change all of my CDN references to use HTTPS, right? I don't care about if I use HTTP2 between the browser and my data center when all I get is my ASP.NET page. It's a single request. I'm not going to roll out Windows Server 2016 anytime soon, and I really don't care because it's not optimized to fix that one request problem, right? It's meant when you have multiple requests. However, if I point to all my resources using HTTP2 and the CDN supports it, then those guys could all take advantage of that, if that makes sense. And then I could do, so I'm trying to decide in this middle world, keep minifying and bundling, and also have another version of it that lets me point to use just HTTP2. That's kind of where I'm at, trying to decide, is that worth the effort or not, based on how many customers I have and who I want to have it be faster for. So again, you can detect protocol version. So some of the things we talked about for detection, if I turned on HTTP2, my load balancer currently supports HTTP2, even though my web servers don't. So I could add, when your request comes to my load balancer, it can negotiate HTTP2. I could add a header then into the request the load balancer sends on to the web server to say, this guy can do HTTP2. Then I'll use all the resources using HTTPS, and they'll get everything fast using HTTP2. Versus I just leave everything else alone and do bundling and everything else and still support the people that do HTTP 1.1. That makes sense? So it's kind of a migration to make everybody happy. And then hopefully in, 4 or 5 years when everybody's using HTTP2 and my server supports it in my production farm, then I can just switch it and get rid of all this bundling and minification and everything else. So quick summary, it really is ready for production. I mean, because it got used so much with SPDY, and if you go out, if you get that indicator and hit major websites, Twitters, Facebooks, they're all using HTTP2. I mean, so they're using it in production for a long time. Some of the features again, binary streams. I really think number 3 is the biggest win. Being fully multiplexed on a single connection really changes the game around how we should approach things, why you don't want to bundle anymore, those kind of things. Header compression is going to make a difference, and again, I'm kind of waiting on server push to see how I feel about that. Some good resources, so you can see different links. The MNOT is Mark Nottingham's, so if you want to follow what he does for being the chair of HTTP2. Ilya Grigorik, who works for Google, does a lot of web performance work. He has a free book on HTTP2. So if you want to read his book, High Performance Browser Networking, it's just good in general. But he has a free chapter with that second link that goes into more detail about the HTTP2 stuff that's really good. If you're still going to be doing 1.1 for a while, this happens to be a really good book on 1.1. That's email, Twitter, blog. That's the link where I have the slides and the code. Again, there's not much code, but from a slide perspective. And we've got about 10 minutes if you have any particular questions you want to go through.
So you mentioned like bundling, changes to bundling, and also CDN deployments. Does it change recommendations on using like the common resources for pulling down your jQueries and your bootstraps?
Okay, that's a good question. So if you reference, in other words,
don't own specifically,
right?
You can
So
pull it from third-party CDN.
yep. So I'll pick like jQuery. So jQuery has a JavaScript file today. They have their own CDN, and that's what you're referring to. And what would I do as a recommendation for that? So
In a HTTP2.
in an HTTP2, I'll tell you the first one, and then I'll add on the HTTP. So in general, I don't like to use third-party CDN stuff because it's another DNS lookup. More likely for me, it's another point of failure. I mean, people say, oh, these things, they fail. So I don't want to add. When it comes to jQuery, I put that today in my own bundle off my own CDN, because then I don't have a dependency on whatever jQuery is using for their CDN. So that's how I would deal with it today. So nothing changes for me from 1 to 2. Pointing to it, 1 to 2 really shouldn't make any difference then either, because you're probably likely only making one connection to them. So them going from 1 to 2, you don't get most of the benefits. You'll get small on header compression and stuff, but I'd say pretty much be the same from 1 to 2.
So don't you actually have like a detrimental effect by you bundling stuff like that? Because the browser, multiple people are probably using exactly the same version of jQuery, pulling it down.
Yep. So the question is, the counter argument to that is, if your customer happens to have already been to jQuery CDN and already cached that, I'm making them download that over again. I don't consider that, well, it's possible that that could happen. My complete bundled, I should look again, my complete bundled compressed JavaScript file is like 150K maybe, which jQuery adds when it's compressed maybe like 20K. I have images on the homepage that are tons bigger than that. I don't want that. I focus more on the detrimental effect of their CDN going down than the slight advantage I would have by leaving it separate and hoping they'd been to that same CDN.
Okay.
But
So it's another script. It's more characters. It's like not a heap of, so you've got a type of script tag into the HTTP as well, in your HTML file.
right,
It's additional script tag. So even then your wins aren't that huge.
right. So that, yeah, and I've had people ask me that before, and some people live on the other side that they like to pull that from the other CDN. I've had my own CDN when I was using a previous CDN. The day I took my bundled files and put it out, they had a failure, and all my pages were blank. I learned how to do fallbacks that night. So you can actually detect that your CDN didn't actually download jQuery and force it to pull it from your own server. So I really care the site works first, because I'm not going to get called about the extra 20K. I'm going to get called that none of your jQuery is working. It's kind of where I land, but yes?
ASP.NET optimizations for all its warts bundles on the fly. Are you aware of any libraries that are able to detect the protocol and unbundle?
So the question was, am I aware of any libraries that automatically detect to and choose not to bundle? I haven't seen or heard of that with any of the ones. That'd be a cool thing, because it would save me from having to do some of that, but I haven't seen anything in particular that does that. Yep.
You started off showing Fiddler as well, but that seems to me that would be a difficult way of, investigating your requests and responses now. So, I mean, you've got headers you don't know about, you've got binary, it's going to have to parse, and then with a single connection. What are we going to use instead of Fiddler?
So I think today most people for HTTP2 are using Wireshark, because Wireshark was one of the very early implementations of being able to understand it and do the decoding and all that stuff. Yeah, I still want Fiddler to work. I mean, I've used Netmon, I've used Wireshark. I don't like assembling packets. At that level of detail, I cared about one day in my life when I used to write protocols for communication and stuff, and then I don't want to see that anymore. So I really want a Fiddler type tool to abstract all that up into a request and a response and hide that stuff. Very rarely, like when I wanted to see how much do I really save with compression, I would go into a Wireshark or Netmon to see how many less packets and stuff I have, but I really want Fiddler to work. So I really want Microsoft, and I mean, the side effect of that is all the other calls I'm making to web APIs today aren't going to support 2 until Microsoft fixes this anyway. I honestly was surprised when I heard it still hadn't been fixed. So that's even probably more important to me, but I like Fiddler too, so that kind of bothers me.
Should we use the server push to replace something like SignalR or Webhooks?
So the question is, could you use server push to replace other stuff like SignalR? You can. I mean, it's a general, it opens up two-way conversations. It doesn't necessarily require that, like, it's not going to scan through your HTML and notice that you're pushing something that you didn't actually have in your markup. So you can push whatever you want to push. The clients can choose when they establish the connection. There's actually part of they set up like a settings frame with the connection to say, I want this or I don't want that. So they can shut off server push. So you just have to be aware. I don't know what % are going to do that. I would guess if people see failures with server push, some people might start turning that kind of stuff off and then you'd be stuck. But it's a general server pushing it to the client sort of protocol. So, okay, yes.
The prioritization stuff, is that something that would purely be at the browser level to implement, or would that, do you think that will work its way down to maybe doing it in JavaScript or HTML?
Yeah, so the question was the server prioritization, or the stream prioritization stuff, do you believe that will ever be exposed to a web developer? I hope it will be. I haven't seen like a JavaScript API for any of that for me to be able to influence and say, I really care that you get this library or this image first. I haven't seen that yet. I really hope that that will be there. Because I would prefer not to. I'm glad browser vendors are implementing some of this for me, but I may have a page, I might leave it 90% of the time, just let it do what it's going to do. But if I have a page with a very specific resource that I want to influence, I sure hope that I have an API to do that.
Something similar to like async on the script tags or something like that.
Yeah. So he said something like an async or something that you could put on the tags. I'm trying to remember if I saw something about link preload that had some influence on that. So let me, if you don't mind, I'll pop out because I think I put something in one of the slides about that. I don't know if I had it on the streams. Okay, I'm thinking of something else. Yeah, so I guess the general is I hope for that. I haven't seen that yet. But. Any other questions?
Got one more.
Yeah.
Just is there any requirement with browsers, like you have 2 tabs open, would they share the same connection, or would they, is that open?
Yeah, so the question is, if you had 2 tabs open in a browser, will they share the same connection? I haven't heard what they're going to do. I would if I were them. I mean, I would literally I want to limit the number of connections I need in general. And if I could share those and multiplex those, and with stream prioritization, I could actually do that, de-emphasize as I switch tab to tab. If I were the browser vendor, I would do that. But I don't know if they're doing that yet or not.
It might be tough for quite a different processes.
Yeah. Oh, yeah.
Bit off topic, but as a HTTP guy, the stale while revalidate, reevaluate, I think it's called, header.
Yep.
Basically, you can say, I think it's only in Chrome, where you can say, do a request for something, and you can say serve at resource saying, you can use the stale one at the moment that you have in cache, but there's another one coming that you should use next time.
I don't think I know that one.
Okay, maybe I'll talk to you later about that.
Yeah, stop up afterwards and we'll see. Anything else? Okay, otherwise, thank you for coming.